Questions 4 through 6 ask us to solve for mass. So start by listing your variables, Q, M, C, and then delta T. And question 1, or 4 I should say, says if 8,750 joules of heat, so that's my Q, are applied to a piece of aluminum that caused a 56 degree increase in temperature, what is the mass of the aluminum? And we are told that the specific heat is 0.9025 joules per gram degree Celsius. So Q equals MC delta T. In this problem, Q is 8,750. M is my unknown. C is 0.9025. And the delta T is 56 degrees Celsius. So let's multiply the 0.9025 times 56, and I get 50.54. Equals 8,750. And then to get that by itself, I'm going to divide both sides by 50.54. And I get a mass of 173.1, and the unit for that is going to be grams. Question 5 asks us to find the mass of a sample of water if the temperature dropped 24.8 degrees Celsius and it lost 870 joules of heat. A couple of key words here. When we're talking about losing temperature or losing energy, you have to represent that with a negative sign. So if we're dropping 24.8 degrees Celsius, it's negative 24.8 degrees Celsius. If we're saying we lost 870 joules, it's a negative 870 joules. Find the mass, and specific heat is blank, but the question told us it was water, so we know that water has a specific heat of 4.184 joules per gram degree Celsius. Let's plug all of our numbers in. Negative 870 equals mass times 4.184 times the negative 24.8. Let's multiply 4.184 times the 24.8. Negative 103.76. That equals negative 870. So to get mass alone, I divide. And I find out that I have a mass of 8.38 grams. If you ended up with a mass that was a negative number, you probably didn't have a negative sign for losing the temperature or a negative sign for losing the energy. If that happens, you can't have a negative mass, so you know to look back and find where your error was. Final question asks how many grams of water would need 92.048 kilojoules of heat to raise the temperature from 34 to 100 degrees Celsius. So we are solving for grams of water. We were given 92.048 kilojoules. It's water, so the specific heat is 4.184 joules per gram degree Celsius. And the temperature went from 34 to 100. So 100 minus 34, the temperature increased 66 degrees Celsius. Now at this point you might be tempted to use all the numbers given to you, plug them into the equation just like we did for 4 and 5. However, the question gave us kilojoules, and kilojoules does not work with our formula. So there are 1,000 joules in 1 kilojoule. If I want to turn kilojoules into joules, I multiply by 1,000. So this becomes 92,048 joules. Once I have that, now I can plug my numbers into our equation. So 92,048 equals M times 4.184 times 66. Multiply 4.184 by 66, I get 276.1 times my mass. And then to get M alone, I'm going to divide both sides by the 276.1. And I get a final mass of 333.3 grams.